Well, good evening. So good to see you. I want to thank you for being here. I'm Lawson Bryan, the senior minister here at the church, and on behalf of all the members of the church and the faculty, the staff of the church, all the faculty of the ECDC and the First School and Mother's Morning Out and all of our staff members, thank you for coming to share this evening together. What a rich opportunity is ours to grow in our own understanding and knowledge tonight. And I thank you for making yourself available for this, because you never know what you might hear tonight that you can then share with someone else. And that's how important information often gets passed on. I want to thank you for being with us for this unusual opportunity to interact with key researchers in the fields of Parkinson's disease and Alzheimer's. For several years, this church has been having Wednesday night speakers on the fifth Wednesday night. When a month has a fifth Wednesday night, we have a speaker of relating to some area of interest for the community as well as the church. And I want to thank Hope Hicks and the members who served with her on the Church and Society work area when that vision was first developed several years ago, and it is continued today under the leadership of Bonner Patrick and those who are current members of Church and Society work area. Now, this is also co-sponsored by the Health and Welfare work area of our church, because they are charged with helping us find ways we can promote the general health and overall welfare of our church and our community. So thanks to Susan Hunt and Laura Rue and those who serve with them on health and welfare. And I also want to say special thanks to Doug Lindley. Doug is sitting right down front here, and we would not be able to gather and have this particular meeting tonight without his leadership. And Doug, I thank you so much for bringing these great speakers to us. Doug is an asset to this church and to our entire community, and has been for a number of years. I want to say thanks to our Director of Communications, Cameron Walker, at this church, who has been helpful in publicizing this event throughout the community. And then also thanks to Daphne Johnston and Laura Rue, who are currently leading us in this church in preparing the way for a new ministry. The name right now doesn't really let you know all that it's going to encompass. It has tentatively been called the Dementia Daycare Ministry. I'm sure there'll be another name for it eventually, because as this ministry develops, it will also be involving those who have had a stroke and those who have Parkinson's disease. And so we're very excited that that new ministry is emerging within the life of the congregation and will be offered to the entire community. Some of you have a card that has their names on it and their email. We have others available here at the chancel rail. If you'd be interested in letting them know of your interest in that particular ministry or being aware of it as it develops, they would be happy to communicate with you. Also, I know some have come as groups tonight from various schools, and if you were to come forward at the end of the presentation and wanted to have your picture made as a group, then we would certainly be glad to accommodate you in that way. Let us pray. Merciful God, we thank you for the incredible healing power you have built into our bodies, and we praise you for the years of research and training that make possible the treatments that support the healing power you've built into our lives. Especially do we thank you for your servants, Dr. Standard, Dr. Gelmacher, and all who work with them, and for the way we see in them the union of head, heart, and hands to promote the well-being of those who battle disease. Sustain them with the knowledge that in serving others, they are serving you. Lord, this is our prayer. Amen. I would now like to call upon Doug Lindley. If you ever have a job you really need to get done, this would be the person that you'd want to call on to do it. Doug, come and give the more personal introduction of our guest tonight.
Thank you, Lawson. And thank you for all the support and encouragement that you have given me. And that goes for the entire ministerial staff and the congregation. Okay, I'm not real good at this, so my wife will coach me from the audience, as she does most every day on everything. Anyway, thank the entire staff and the congregation for their support of me. One want to recognize a few people that are here tonight that are instrumental in Parkinson's Association and Parkinson's groups. Ken Cater is the president of the board of directors of the Parkinson's Association of Alabama, and he drove down from Birmingham tonight just for this event. Ken, would you stand? Is Nancy McLean here? Okay. Nancy has been instrumental in helping us connect with the Alzheimer's community. Susan Bray has been just a rock for years in terms of running the support group that has become Cloverdale and does a wonderful job. And Kate Tully is here she's with the UAB Department of Neurology as the Associate Director of Leadership Giving and Community Relations. Pleasure having you here, Kate. I'm going to introduce the first speaker first, and then after that, he will take questions, and then I will come back up and present the second speaker. Our first speaker tonight is Dr. David Standard, and on your program, the only thing that's incorrect, since we had him printed, he is now the chair of the Department of Neurology at UAB Medical School. And by now, most of y'all have seen his bio and are aware of his outstanding educational and professional background. So I'm not going to go over that again. Rather than repeat that, I'd like to discuss two words that are constantly associated with him by those who know him well. The first of these is hope. One of Alabama's great citizens, Helen Keller, said, "Nothing can be done without hope." Dr. Standard brings hope through his quiet confidence and openness on what progress is being made in understanding Parkinson's and its possible causes and new treatments. He brings hope through his recruitment of the best and brightest to the research team at UAB's Department of Neurology. He brings hope through his compassionate response to the real-life difficulties of Parkinson's patients and caregivers. And he brings hope through his passionate and relentless pursuit of a cure for Parkinson's. The second word associated with him is care. He cares enough to drive 100 miles after working all day to help educate us regarding Parkinson's and to answer our questions and concerns. He cares enough to see patients most Fridays in order to understand the quality of life issues that are important to those afflicted with Parkinson's. He cares enough to share information and to support worldwide efforts to find a cure sooner rather than later. He cares enough to be ever mindful of the significance of giving people hope. As brilliant a scientist as he is, his compassion and character are equally impressive. Please welcome the world-renowned physician scientist on Parkinson's disease, Dr. David Standard.
Myself from your microphone. All right, well, I had to thank you, Doug, for that very generous introduction. That is the kind of thing that you only hope that you can live up to. I'll get my slide control here. And I want to thank the senior pastor and the church for the opportunity to come and speak to you this evening. This is a real privilege. It's wonderful to see so many people turn out to learn more about Parkinson's and Alzheimer's and what we're doing to try and combat these diseases and get to better cures. So I really do appreciate the opportunity to speak to you. What I plan to do is, I don't want to take too much of your time this evening with talk. I want to tell you a little bit about Parkinson's, give you some of the background, tell you what's exciting in this field, because there is a lot of excitement. We don't have a cure yet, but I really believe that it's possible to find one, and we're going to do our best to do that. And I'll tell you a little bit about how much progress we are making in that direction. And then I want to give you some opportunity to ask questions of me. We'll then move to Dr. Geldmacher, who's going to talk more about Alzheimer's disease. And I think if there's some time left at the end, we probably can both take collective questions that may be shared related to these two conditions. So let me move the slides ahead first. Just to tell you a little bit about Parkinson's disease, Alzheimer's disease, and put this in the context of what we call neurodegenerative diseases. So these are all disorders where there are neurons in the brain that are dying off sooner than they should. There is some loss of brain neurons as we age, but as you know, many people can live into a very old age with very good function. So decline in brain function is not a necessary thing in life. Many people live well beyond 100 and are doing quite well. So when certain parts of the brain are prematurely degrading, that leads to a neurodegenerative condition, and depending on which structures are involved, you get different kinds of symptoms and different kinds of complaints from that. This is just a slide that illustrates some of the major disorders, exemplified by some of the people you may recognize. Of course, here's President Ronald Reagan, who really is an emblem of Alzheimer's disease. Michael J. Fox, who has become a prominent spokesman for Parkinson's disease. Probably some in the room know Woody Guthrie. Woody Guthrie was a folk singer, but also affected by Huntington's disease, a neurodegenerative disorder. And this, of course, over here is the famous ball player Lou Gehrig, after which Lou Gehrig's disease, or ALS, is named. The point I wanted to make here is that these are very common. There's about 5 million people in this country right now who are affected by Alzheimer's, another 1.5 million affected by Parkinson's. Smaller numbers of these disorders, but these are just as difficult as the more common ones. So they're a very frequent problem right now. In fact, our society struggles to care for these people and to provide appropriate treatment. The other thing to appreciate, though, is that we are succeeding in living longer in this country. That's a great advance in medicine. We've eradicated polio. We've stamped out other diseases. We've done better with stroke and high blood pressure. And a consequence of that is that many of us are living longer. That's good, but the downside of that is that these diseases are all age-related, and they're going to become more common as people live to an older age. And if you calculate this by 2050, which used to sound like a long time away, but now it doesn't sound all that far, you'll have 14 million people with Alzheimer's disease, over 4 million with Parkinson's, and another couple 100,000 with these disorders. So if we can't really cope with 5 or 6 million people with Parkinson's and Alzheimer's right now, you can only imagine what it would be like when this country has to struggle with 20 or 25 million people affected by these degenerative disorders. There's no way to stop this tidal wave short of finding better treatments and finding a cure. So I think it's really an imperative for us to push ahead and find better treatments. It's the only way out of this demographic process, which will otherwise burden us with a lot of folks and burden a lot of people with chronic disorders. In terms of Parkinson's disease, it is a very common disorder. I think practically everyone I've ever met has seen somebody with Parkinson's, knows somebody with Parkinson's, maybe even has somebody with Parkinson's in their family. Actually, my grandfather died of Parkinson's in the mid-60s. That's not really what sent me down this road. I got to this disease and my work in another way, and it was almost an odd thing for me to realize that, in fact, I had a family connection as well, and most people will have some connection to this. The reason for that is it's very common. About 2% of the population over the age of 65, so that's a quite frequent disorder. The features of Parkinson's are really the signature by which we diagnose it. So it's a very insidious disease. It comes on slowly. The most common symptom that we see, or most common complaint that someone will come to see me about, is tremor. It's a very particular kind of tremor, usually on one side of the body. It's a shaking, rolling tremor, usually there when the hand is quiet. If they go to do something with it, it goes away for a while. Then when it goes quiet again, it comes back. I often ask people, for instance, when you read the newspaper, does your hand shake? When your mind is on the news, shaking that paper is a very typical symptom of Parkinson's disease. So not all tremors are Parkinson's, but that kind of one-sided resting tremor is a signature of the condition. Also produces what we call rigidity, which is stiffness, a lot of slowness of movement, slowness of the body as a whole, slowness of the fine movements, and Doug will know everyone comes to my office, I ask them to do this. I've had people come in and say, I've been practicing, how is it now? And I guess practicing helps a bit, but it is a test we use because this slowness of very fine movement is characteristic of Parkinson's. And then as a late feature, postural imbalance, meaning loss of balance, falling. Not an early problem, but as the disease advances. We have some very good treatments which can treat the symptoms. And so most patients with Parkinson's who come to see us, we can actually make a big difference in their lives. I occasionally have the opportunity to see someone who has had Parkinson's for a number of years, never been treated, might come in a wheelchair, and if you decide to treat that person right in the office, they might get up and walk out under their own power. Now that's a great thing, but none of these treatments correct the underlying disease. The treatments we have restore the chemical deficiency that's produced by Parkinson's, but they don't get at the root cause of the problem. So I tell many patients, we win a lot of battles in Parkinson's, but in the end, we don't have a way to win the war right now. These are some famous people with Parkinson's. This, of course, is the Pope, Muhammad Ali, Michael J. Fox, and then this person here doesn't have Parkinson's, but he's in the picture because Ken Cater and I were there when he did a fundraiser with Michael J. Fox. This is Roger Daltrey in The Who, did a fundraiser for Michael J. Fox a couple years ago. So what causes Parkinson's disease? I think everybody who comes to see me says, why do I have Parkinson's disease? Why did it happen to me? Did I lose my mic? Okay. Yeah. You want to just clip that on?
Yeah, let me try it right here.
All right.
See if I can put it on your tie. Right
Sure.
that way. All right, let's try this.
Yeah, that might be a little more.
Give that a try.
All right, how's that? Is that better? Okay. All right, so practically everyone wants to know why me, what causes it, what is the cause, what is the trigger? And honestly, for the average person who comes to see me, I have to say, well, honestly, I don't know. That's not really within our knowledge as physicians. I don't have a root cause answer, but we are studying this, and some important clues have emerged. One of the things to know is it's not generally a familial disease. So many people are concerned, I have Parkinson's, what will happen to my children? Are they at risk for getting this disorder? And I say, well, they're the same risk as the rest of us, about 2 or 3% in our lives, but generally speaking, the child of someone with Parkinson's doesn't have any higher risk than the child of somebody who doesn't have Parkinson's disease. So it doesn't tend to run strongly in families. People have looked for a cause in the environment. So you say, well, it's not inherited. Maybe there's something out there. Maybe there's a poison, a toxin, which can cause Parkinson's. There are some examples of a way in which this can happen. There's a famous group of patients in Southern California who were trying to make an illegal drug of abuse in their garage and made a mistake in their chemistry. So two episodes of bad judgment on their part. And the upshot was they made a toxic chemical which, when injected, caused them to have severe Parkinsonism. This is quite rare. It was an important clue to the disease, but that kind of toxin or chemical doesn't seem to be in the environment very much. There is some research emerging which suggests that people who are exposed to pesticides in very high doses, not the kind of thing you would get from your garden, but if you were to fly a crop dusting airplane and spray large quantities of pesticides, that may increase risk. Most of this research is coming out of California, where they have very detailed records of this kind of thing. Still, nothing in the environment that we've identified today explains the majority of people who have Parkinson's. It is more common in men. It's about twice as common in men as in women. Why that is unknown, but it's a clue to the biology of the condition and something we're very much interested in pursuing. And there are some genes that cause Parkinson's. So we have found some families around the world where Parkinson's does seem to run strongly. These are quite rare, but they're very important clues for us in trying to understand the basic biology of the disease and how you might attack it. All right, so just to say something, I don't want to go through a detailed discussion of the current treatments of Parkinson's. There are quite a few, and I spend a lot of time in the office talking to people about the treatments, using these treatments, and as I said, you can often take somebody who's never been treated and really transform them for a period of time with the treatments we have. Some of these are things like levodopa and drugs like ropinirole and pramipexole. All of these are good treatments. They're very helpful. I think they've really helped improve the quality of life of many people, but none of these are a cure. And the reason is that they suppress the symptoms, but they don't get at the root cause. The root cause here is a degeneration of the brain. That's a loss of neurons, particularly those that make a chemical called dopamine. And if you're not replacing or restoring those neurons, you're really not slowing the underlying process. So what we're after are things which are neuroprotective. By this we mean they would protect the brain against the course of the disease. You might say, well, how can we protect ourselves against anything? We actually have medications that protect us against things like high blood pressure. If you have high blood pressure and you take a medication for it, you will greatly reduce your risk of stroke and heart attack and all kinds of other consequences of that. So it is possible for us to find a treatment which can protect you from something like high blood pressure. So why can't we find a treatment that would protect us from Parkinson's? And in Parkinson's, we have a particular opportunity because it's a very slow disease. It begins a long time before the symptoms appear. We actually think it may begin as much as a decade before the first signs appear. So someone comes to see me and they said, I'm really upset, I've developed Parkinson's last week. And I say, well, no, you didn't. You developed it 10 years ago. You just noticed it last week. And that really is the case, that it comes on that slowly It's going on in the brain for a decade or more before the symptoms become apparent. So since it's so slow, we have some opportunity to intervene if we can find a treatment. So another way to think about this, and this is a kind of graph here, function over time. If you think in normal aging, we might lose a little bit, but a lot of folks do really well into very advanced years. In Parkinson's, something happens. There's a decline in brain function, and at some point, it becomes a decline in physical function. You become aware of it, and that progresses over time. And what we're after here is something that would change the game, change the slope, flatten this out, and protect us from this advancing disease process. So that's the goal. How do you do it? It is a process where you start way upstream with ideas about what causes the disease, models of the disease. We really can't study experimental treatments in humans unless we're sure they're safe. Very difficult to study things in humans. So we study things in cells, we study things in worms, we study a lot of mice, other kinds of simple models to understand the disease. Once you find something like that, you might develop a drug or a chemical, and we have groups that are doing that. And then you take it through a period of testing in humans to show first that it's safe and later it's effective. It takes 10 years or more typically, sometimes 15, to move through this process. And one of our goals at UAB, Dr. Watts initiated this process, and he and I have worked on this together, is to bring together the scientists and the clinicians and the patients to try and move this process faster, to do better than 10 years. As Dr. Watts often says, we haven't met anyone yet who wants us to work more slowly. They all want us to work faster, and that's what we're interested in doing as well. So the thing that brought me to Alabama, you can probably tell I'm not from here. I grew up on the East Coast. I'm actually born in New York City and grew up in Maryland largely. But I came down here 5 years ago to build something called the Center for Neurodegeneration and Experimental Therapeutics. So this was to be a group of scientists that would work in a neurology department but really focus on finding novel treatments and cures. And this group has grown tremendously. These are now the 6 principal scientists in this group, so it started with just myself. In fact, early on, I used to show this slide as a blank slide just to illustrate where we began. And now we've got a group of 6 very talented scientists from around the country, people with outstanding resumes working in Parkinson's, Alzheimer's, Huntington's disease, and ALS. How do we do what we do? Well, let me give you just a few highlights of things that are going on in our research and in the research laboratories and in the clinical trials. I'll talk a little bit about 2 groups of proteins. One has the unpoetic name of a 1433 protein. Sounds like a scripture verse or something, I guess. And the other is LRRK2. We'll talk a little bit about inflammation as an area that I'm particularly interested in. And I'll tell you about 2 new clinical trials that are producing potentially very exciting results for the field. So just to give you a big view of how this works, a lot of what we do really starts in mouse models. As I said, you can't really do this kind of discovery work in people. It's not safe. We can't put them at risk when we don't know what these treatments might do. But we have a lot of mice, and these gene discoveries have led us to develop mice which have genetic modifications that model Parkinson's. From there, we can study the genes that are altered in the mice, and you can pull things out. And one of the things we pulled out was this group of proteins called the 1433 proteins. These are proteins that are present in all of our brains, but the work in the mice suggested that when they go astray or go wrong, it might contribute to the biology of the disease. From that, you can put these back in cells and test them. You can build assays or ways of measuring the function of these proteins. And ultimately, you can come back around to actually doing chemistry, discovering chemicals that would change the way these proteins work. So we've been working on this. Actually, this was driven largely by my colleague, Dr. Telling Yakubian, another Harvard-trained physician who moved here to Alabama with me 5 years ago. She identified these as a possible suppressive target, as a place where you could make a drug, and if the drug stuck to these 1433 proteins, that might be something that would be a treatment for Parkinson's. We haven't gotten all the way there yet, but we do have a patent. The U.S. Patent Office took us seriously enough to actually issue a patent to UAB and Dr. Yakubian and I for the use of these proteins as a target of the treatment of Parkinson's disease. You might say, why do we care about a patent? UAB really isn't in the business of patenting things and making money, but it actually is important. If you don't have a patent, you can't get a major drug company interested in your discovery, and we want to take our discoveries to the level where you can buy them in CVS or Rite Aid. That's ultimately where we're trying to go with this. Having this patent in hand, we can then go to what's called high throughput screening, and this discovery is just in the last few weeks actually arrived at this stage. This is a set of robots they have at Southern Research, our partner in Birmingham, So it used to be that when we studied something in the lab, we could do maybe 1 or 2 tests a day, or 3 or 4, or if I got a whole bunch of students and put them at it, maybe I could do 8 or 10 different tests on a chemical during a day. But that was about it. These machines will let us test 50,000 or 100,000 different chemicals against this target in a single day. So in an afternoon, we can run 50,000 experiments and look at the results of all of those, pick out the one that works, and move that down the line. So this is a tremendously powerful way of moving forward, and we're doing with this family of proteins. Another protein that has reached this kind of stage is one studied by Dr. Andy West. It's called LRRK2. Not a very good name, not very poetic, but it's a very important protein. Causes probably about 5% of all human Parkinson's disease and may contribute to all forms of Parkinson's. And we've used this to make mice, to make flies, to make different kinds of models. And Andy has now taken this to the robotics lab and has actually discovered some drugs which are very powerful inhibitors of this, much better than anything seen before. We're getting ready now to do further testing on these and probably move them to a mouse model within a year, I would guess. All right, and lastly, a little bit about inflammation. So we all know about inflammation. You think about stiff joints or maybe a rash on your skin or something like this is part of an inflammation process. There are lots of disorders that are caused by inflammation. In fact, there's good evidence that heart disease is partly caused by inflammation in the arteries. Inflammation in Parkinson's was always really not an area people dug into very much. We knew that if you looked at the brain of somebody who died from Parkinson's, there's a lot of inflammation there, a lot of immune cells that were very active. But everyone said, well, that's because there's degeneration, things have died off, these things have been turned on by that. But our work and work in a couple of other labs has turned this around and is starting to make the case that, in fact, this state of inflammation, this state of abnormal immune activation may be part of the process. Something sets off Parkinson's in your brain, and what makes it get worse over time might be the immune system driving it. That's very important because we have a lot of medicines which treat the immune system. There are things like steroids, there are special infusions that are used in conditions like rheumatoid arthritis. There's a whole area of science of changing the immune system which has never been applied in Parkinson's. So what we're trying to do is to make the connection between inflammation and Parkinson's that will enable us to then access that whole body of knowledge around inflammation as a treatment for the disease. This is some inflammation in human brain. These green colors here are microglial cells, kind of the brain's scavengers activated in Parkinson's disease. This is a brain scan from a human Parkinson's patient. And this red doesn't show up all that well in this bright room, but that's okay. I don't want to turn the lights down too much and put everyone to sleep. The green cells here are dopamine cells, and all these red cells are angry, unhappy immune cells that are attacking this system in this mouse model of Parkinson's. So this is a hot area for us as well. What about clinical trials? So all of these things I've been talking about are very upstream: mice, proteins, cells, chemicals that have never been used in humans. What's going on at the other end? So at UAB, one of the things we've done is we really are studying the whole spectrum. We have very world-class scientists studying the mice and the proteins and the chemicals. We also have a big clinical research program. Our clinic at UAB sees about 5,000 people with Parkinson's a year. We have clinical trials, about 20 or 22 different trials running at any given time, where we're testing drugs at different stages. Let me just tell you about 2 of these trials, just to give you some insight into where the field is going. The first one is something called the PPMI study, Parkinson Progression Markers Initiative. This is a study funded by the Michael J. Fox Foundation. And it's not a treatment. This is a study of very early Parkinson's, really with the goal of asking whether we can make a test for Parkinson's. Can we detect the earliest changes of the disease and use that as a way to attack the condition? To study this, we're getting people with very early Parkinson's, not on any medicines, and we're getting people who don't have Parkinson's who are willing to come in and be a volunteer. I have to say, Doug Lindley has helped us greatly, and I think some members even of this church have been involved in this process of volunteering to participate as normal controls in this. It involves testing, spinal taps, collection of blood, brain scans. It's a kind of laborious study, but it's very important for us to understand what goes on early in the condition. And the Fox Foundation has gotten interested in this to the tune of about $40 million so far, which is a big investment, but I think it's really going to pay off. Alabama is actually one of the top sites in the country now. They were shocked in New York. They thought in New York City they should be able to recruit people, but we're way ahead of New York City. And they're very impressed with what we're able to do here in Alabama and the role that people in the community have in stepping up and being willing to be part of this. Another trial that's way at the other end of the spectrum is something called Serogene. This is a company in Chicago that has developed a treatment that's a virus for Parkinson's. So it's a virus. What you do is you actually drill a hole in the head, you inject it into the brain, and it makes a growth factor. Dr. Watts likes to call it miracle grow for the brain. I don't know if I like that analogy quite, but it is a kind of fertilizer. It's a way of turning those dopamine neurons back on and promoting their regeneration. This is very promising in early stage trials. We're now into a second phase of trials with this. And what's exciting about this is potentially a treatment which could not only stop Parkinson's, but maybe turn the clock back. You may be able to take people who have fairly advanced disease, put this virus in, generate the growth factor, and actually have that part of the brain grow back or regenerate. So I think that's a very exciting potential and shows you the kinds of things that are not too far out on the horizon. If this trial works, this could be available as a treatment, I would say, within 2 or 3 years if the trial's successful. So keep your eyes out for that. So let me just close by telling you a little bit about our goals here. What are we with the Center for Neurodegeneration and Experimental Therapeutics? Well, as Doug told you, I was recently named the chair of neurology at UAB. That's a tremendous honor. Only the 4th chair of this department in its 40-some-year history. We have big plans to grow the department, to grow neurology at UAB, and specifically to expand these research groups working in Parkinson's and Alzheimer's. We're going to continue to recruit from outside, and we're going to grow from within. We're going to find the best talent locally and in our university and bring them up as well. We're also committed to clinical care. We do a lot of clinical care, and we're committed to having the very best in clinical care and clinical research available to people in Alabama through the clinics at UAB. And finally, what we really want to do is we want to discover the cures of the future. It's great to be able to treat Parkinson's and help people, and I enjoy doing that on Friday, and I really get a lot out of that interaction, but I'd like to come in and deliver a cure. As I said a number of times, I would really love to find a cure and put myself out of business. I'm very happy to go find another line of work. All right, so this is our contact information. I'll be very happy to take a few questions here, and then I'll take a few more maybe after Dr. Geldmacher has a chance to speak. Would he be a candidate for the Serogene study? Well, each of these studies has a very specific entry criteria, and the reason for that is in a study, we can obviously only study a small number of people, and we need to have a very uniform group. Now, whether he would be a candidate or not, we'd have to sit down and talk with him. The people for that particular study do have to have pretty advanced Parkinson's, but they still have to have intact mental function and at least be able to engage in some of their own daily activities. So it's possible. You know, the best way probably is to speak with one of the physicians at UAB or have him come up at least for a one-time visit to our clinic and see what kind of trials. If he doesn't fit into this study, but he does want to be in research, as I said, we have a whole range, and it covers the spectrum from very early to very late. But you know, the spirit of joining in the trials, we need people to sign up and join these trials because we can't find this alone. We need the assistance of the community and the assistance of people affected by these conditions and the families to step up and help us out with this. Other questions? There's one way back there. I think Doug's got a microphone for you here. Let me get the microphone here. I can't quite hear you.
Yes, sir. I know we don't know the cause of Parkinson's, but are there any lifestyle factors that contribute to it that you know of?
Well, there are a few lifestyle factors that have been studied. For one thing, caffeine. Coffee seems to reduce the risk just a little bit. If you're going to do that, the right amount is between 2 and 4 cups a day. That seems to be the right dose of coffee to reduce the risk. It also seems that smoking reduces your risk of Parkinson's. Of course, you get lung cancer instead. So we do not recommend smoking as a treatment for Parkinson's or as a prevention for Parkinson's, but that's interesting to us why that would work. Probably, you know, cigarette smoke has a whole variety of toxic chemicals in it, and probably one or more of those has something to do with dopamine metabolism, but we're not really sure. So those are the main features. Also, people who live in rural areas do seem to have a higher risk, and that may involve this pesticide connection. But still, even if you add up all those features, it accounts for only a small part of the disease. It really doesn't explain the big picture. I think it was somebody else back there with a question too, Doug. There were, no? All right, there's one up here. Cognitive deficits in Parkinson's disease. Yes, there are, and this is something that we have recognized more and more. So although we talk about Parkinson's as being a disease of tremor and stiffness and slowness, that's why we call ourselves movement disorder doctors. Although sometimes when people think movement disorders, they're thinking about gastroenterology and not so much Parkinson's disease. I get that problem periodically, but we call ourselves movement disorder doctors because it is about movement and tremor and stiffness and slowness. But as we've gotten better in keeping people going and sustaining them through that, actually you do find that there are cognitive abnormalities that develop later in the course of the disease. And when I first started in this field, it was said that 10 or 15% of people would get cognitive troubles. We keep them alive longer, and now the number has crept up to 30 or 40 or maybe even 50. So I think that cognitive problems are a part of the condition. It's part and parcel of the process of Parkinson's. It's somewhat different than Alzheimer's, but it's no less disabling. So it often is the problem in the end. And that's another reason that we really need a preventive treatment. Our treatments are all about replacing dopamine and helping movement and stiffness and slowness. The treatments we have really don't do a lot for the cognitive aspects. To tackle that, we need a cure for this disease. One more over here, and then we'll let Dr. Geldmacher talk. Are there new medications other than Sinemet? Is that the question? Yeah. So there's a long list of medications other than Sinemet. There are drugs in a variety of classes. Most of them work through replacing dopamine one way or another, boosting dopamine in the brain, preventing the breakdown of endogenous dopamine. So it's a list of about 12 or 13 drugs, I guess, that are approved for Parkinson's disease use. And juggling these things is a lot of what we do in the clinic. And they all have their uses and their roles, but at the end of the day, none of them is really the cure that we're after. All right, so maybe I'll let Dr. Geldmacher talk, and we can come back to more questions at the end. All right, thank you.
Our next speaker is Dr. David Geldmacher. I had the honor of meeting him at the AIMS Symposium. AIMS is the Autauga Montgomery Elmore Seniors. It's the Alzheimer's support group in the area. He did a presentation earlier this month. I was very impressed with his teaching and his presentation. He joined UAB in March as director of the Division of Memory Disorders and Behavioral Neurology and as a professor of neurology. Prior to coming to UAB, he was a professor of neurology at the University of Virginia. So rather, again, than repeating the bio, I don't know as much about him personally as I do Dr. Standard, but I will say this with confidence. He has to be one of the best physician researchers, scientists in the country on Alzheimer's and memory disorder to be at UAB, because they're the world-class program they're building. They're attracting the best and the brightest. So please welcome this nationally recognized physician scientist on Alzheimer's and memory disorders, Dr. David Geldmacher.
Well, thank you very much, Doug. It's a genuine pleasure to be here with you tonight, and I am honored to be a part of the UAB faculty and a part of the medical community here in Alabama to help address these issues. And I agree with what Doug has said. The program, this world-class program at UAB, is one of the main reasons that I'm here. I was pleased to be invited to join it and honored to be selected. Let me talk a little bit about the world of Alzheimer's disease and Alzheimer's disease research. Many of the messages in Alzheimer's disease are quite similar to the messages that Dr. Standard talked about in Parkinson's. They share many properties. Both are diseases that affect the brain and occur more often as we grow older. Both are diseases where our best understanding of the illness comes from changes in proteins in the brain. And like Parkinson's disease, we have symptom-based treatments. We have treatments that might enhance memory or delay the worsening of the memory. We have treatments that can reduce some of the changes in thought, like delusions or hallucinations, but we can't yet address, or we are not yet addressing, the basic underlying problem in the illness. Alzheimer's disease follows a history over the last century of progressive increases in knowledge and reframing of our knowledge. In terms of medical history, Alzheimer's disease is about 100 years younger than Parkinson's. It was first found in 1906 by Dr. Alzheimer, a German scientist, who followed the course of a woman who was in her 50s with progressive cognitive decline and memory loss, followed her to the point of death, and using some of the advanced technology of the day, examined her brain under the microscope and found the characteristics that we still use today to characterize Alzheimer's disease in autopsies. And that would be the two findings called the senile plaque and the neurofibrillary tangle. So for the last 100 years, 105 years now, that's been the defining features of Alzheimer's disease. But our knowledge about how people are affected by the disease has changed over that 100 years. It was in the 1960s that the idea that Alzheimer's disease was a pre-senile dementia and somehow memory loss in later life was something different began to break down. And by the 1980s, it was recognized that Alzheimer's disease was the single most common cause of dementia in people anywhere from their 40s upward. The other thing that was discovered in the 1980s was the characterization of what that abnormal protein in the brain of the Alzheimer's patient was. It's called amyloid protein, and for many years it wasn't clear what kind of protein it was. But once we knew the order of the building blocks of that, it allowed us tracing it back to the genes that might be related to making it, and as Dr. Standard mentioned, putting those genes into mice so that we could then begin to express the illness. And it wasn't until the 1990s that we could study Alzheimer's disease in a way that didn't involve people with the disease, that we could actually start to do some of these more risky and aggressive treatments because it was mice rather than people. On a separate line of development in the 1990s, our first prescription medicines came to bear, again, about 30 years after the first Parkinson's prescription medicines came out. The medicines in Alzheimer's disease are not as successful at reversing the symptoms as the Parkinson's medicines have been, and we continue to work toward better treatments, both for the symptoms and, as with Parkinson's, to treat the underlying process in the brain that leads to the symptoms. The biggest breakthrough in the last decade has been the ability to find the disease process before the memory loss begins. So as Dr. Standard mentioned in Parkinson's, the brain function is changing before the first symptoms emerge, and now we know the same thing to be true in Alzheimer's disease, that we can find changes in how the brain is managing these proteins in the years and probably even more than a decade before the first forgetfulness becomes different than the aging process. So I've tossed around some terms, and I want to be very careful in clarifying what I mean when I say these terms, because they might be different than the way you've heard them used in the past, but they reflect what our research is telling us about the processes of Alzheimer's disease and the processes of dementia. So I will use the word memory loss as a kind, or the words memory loss, as a kind of jargon for saying the symptoms of dementia. It's memory loss and much more. It's not just forgetfulness. It's a change in the way we process the world around us, the way we see, the way we understand language, the way we can coordinate movements like using a knife and fork. All of those fall within the symptom patterns of Alzheimer's disease. But I'll be calling it memory loss just for the purposes of succinctness. Dementia is a word that confuses many people. Dementia means a loss of intellect or cognition or behavior that's severe enough to interfere with the way the person conducts their everyday activities. So if your memory loss is severe enough that you can't do what you used to do, that's dementia. And there are dozens of causes of dementia. The most common is Alzheimer's disease. Others might include strokes or vitamin deficiencies. And so when we say dementia, we're just describing that syndrome of a change in brain function that leads to a change in day-to-day abilities. And that might be like saying back pain, because there are dozens of causes of back pain. There could be a slipped disc or a pinched nerve or a crushed vertebrae. All of those cause back pain. When we talk about Alzheimer's disease, we're talking about one cause of dementia, one very specific cause of dementia that we can identify under the microscope by those plaques and tangles that Dr. Alzheimer first described, and that we can recognize in the clinical patterns of the way the people remember and forget, the way they handle certain kinds of problems in the testing situation. So Alzheimer's disease is a cause of dementia. This is important because just earlier this year, the rules for diagnosing Alzheimer's disease were rewritten a little bit. And now it allows us to make the diagnosis of Alzheimer's disease in a person before a full-blown dementia is present. We can do that with testing. Not all that testing is available to the doctor on the corner yet. Most of it is still research testing. But we can now begin to step backward in time in the disease process and identify it before the symptoms come up. That's a very important step toward cure. If you think about what we do for heart disease, we find the heart disease when the first symptoms, long before the first symptoms come up. We find it when the cholesterol level is too high in the blood. And we begin to treat that cholesterol level, and we prevent that heart attack down the road. So now with Alzheimer's disease, we're on the very cusp of being able to find the disease consistently before the symptoms emerge and treat it for prevention. And that's very close. This is not an accident. Dr. Stander showed the numbers. 5 million people with Alzheimer's disease today, 15 million by the middle of the century, and that's not that far away. And to address that need, medical research in Alzheimer's disease has exploded in the last 30 years. In 1980, in using the Medline, the Library of Congress's search for scientific journal articles, in 1980 there were only about 100 articles on Alzheimer's disease in all of the scientific literature. 30 years later, in 2010, there were almost 4,000. So 35-fold expansion in the amount of publications on Alzheimer's disease in those 30 years. And this effort is worldwide. At the very first International Conference on Alzheimer's disease in 1988, there were about 300 scientists in attendance. Last month in Paris at the meeting, the international meeting, there were over 5,000 scientists, hundreds and hundreds of presentations, literally thousands of conversations among the researchers and the clinicians, the people who work on finding the cure for the disease. This is a worldwide network working to find the cure, and UAB is an important part of that network. In the United States, UAB's Memory Disorders Program participates in the major initiatives, the Alzheimer's Disease Cooperative Study that tests new medicines, the Alzheimer's Disease Neuroimaging Initiative that tries to find the disease before the symptoms emerge, and the National Alzheimer Coordinating Center, a database of more than 30,000 people in it who've had Alzheimer's disease and been followed through, so that we can start to extract the themes from those people. And as I said, UAB has been a contributor and a participant in all of those networks. There's been a change in the way we think about Alzheimer's disease in these last 10 years, an accelerating change. The traditional view is that the amyloid protein builds up into those plaques in the brain, and those plaques are what does the damage. And the thought has been if we could remove the plaques, we could fix the damage. And so that's illustrated here. Down in the lower right are the healthy brain cells that look a lot like trees with a root system and a branch system, and they're densely interconnected like the trees in an old-growth forest. And the idea was the plaque got in the way of those connections and pulled them apart so the brain cells couldn't talk to each other. And that's true, but that's a late step in the disease process. And now, over the last several years, it's become clear that the amyloid protein that builds up in the brain of Alzheimer's disease is toxic to the brain cells before it builds up, before it clumps together into those plaques. And it starts to interfere with brain cell communication long before, or I can't say necessarily long before, but in a molecular process, much earlier than it clumps together in those big plaques. That gives us a new target to treat. That means instead of trying to remove plaque from brain, maybe we can prevent the amyloid toxicity. And this has opened up many new doors in the ways of thinking about trying to prevent the damage to the brain in the Alzheimer process. So we have two options then, where we have two clear things. If we can find the disease before the symptoms emerge, and we can prevent that molecule from doing its damage, we can prevent Alzheimer's disease. We can cure it. And that's where the research process is taking us. We are not there. There's going to be a lot more work before we get there. We need to find drugs that are safe in people and effective at blocking that toxicity without causing other damage. And that's been one of the big challenges, that when you block these fundamental protein pathways, you can also block important normal pathways for those proteins and cause damage. The idea with the treatment as we move forward is going to be prevent the collapse of the brain cell, to prevent that tree from twisting in on itself and pulling away from the other brain cells. That twisting in and pulling away is what the neurofibrillary tangle is. That's the second thing that Dr. Alzheimer found. So he found the plaque and the tangle. And if we can intervene before the plaque is formed, we might be able to prevent the tangle. And there's very important research that's been going on that tells us we're on the right path for that. The other question that we have is, are all Alzheimer's disease patients the same? Are all cases really based on the same origin? And the answer to that is probably not. Just like Parkinson's, very few cases of Alzheimer's disease are linked to a specific gene that causes the disease. Probably less than 2% have been linked to specific genes. Those genes are all associated with making too much of the amyloid protein. But if 98% of the cases are not associated with genes, we may need to find another source for the disease in those people. And so maybe the problem isn't making too much amyloid in the average person who's 65 or 75 or 85 when they get the disease, but rather maybe it is we can't get rid enough of it. We can't get rid of it quickly enough. And the analogy I like to think about here is the slow bathtub drain. So your faucet may still be making the same amount of water, bringing the same amount of water into the tub or in the brain, making the same amount of amyloid and bringing it into the brain. But the problem might be in the aging process that we're not as good at getting it out of the brain. So instead of focusing on the front end of putting too much water in, maybe we should focus on the back end of getting more water out. And if I change the word water to amyloid, maybe our new treatments will not focus on producing too much amyloid, but rather focus on helping get it out of the brain. There are at least 12 genes that have been identified that may contribute to the risk of Alzheimer's disease and are associated with slow removal of the amyloid. That gives us 12 new targets to work for. And I hope that in the next couple of years we'll be in the position at UAB of screening routinely for those genes and being able to start to understand how they influence the expression of the disease and help us understand what targets there will be for treatment that take a different approach to what's been done over the last couple of decades. So the next thing we need to do is to move that from the laboratory to the clinic. And that's really where my role is. I'm not a laboratory scientist. I do not have the test tubes and the robots and those sorts of things. That's not my work. My work is helping to understand, helping to guide the scientists as to what molecules might be appropriate to bring to the clinic, and then how do we implement them into the clinical setting? How do we use them in people affected by the disease? This is some of the data that tells us that we can bring those treatments to the clinic earlier. I mentioned our participation in this national network called the Alzheimer's Disease Neuroimaging Initiative, and this is their work. It tells us that we can begin to find changes in the brain proteins. This is measured in the spinal fluid, but we can begin to find changes in the brain protein long before symptoms come up. So this means that you might be able to go to your doctor someday, volunteer for a spinal tap, have that protein measured, and know that there's a problem going on and allow us to target the treatment ahead of time. By the time people get to significant changes in memory, the state that we call mild cognitive impairment, there are many other markers that we can use. One of the important tests that we want to develop is to be able to find these markers in the blood, because I don't have a lot of people leaping forward saying, please doctor, give me a spinal tap. But there are many more people who are willing to get blood work tested. And so that's one of our goals, is to move toward finding these kinds of abnormalities, not only in the spinal fluid, but also in the blood. We've made real progress in being able to target the amyloid protein. And there's both good news and bad news with that. This is a study that used an antibody against the amyloid protein. So essentially, turning on the immune system, or putting immune proteins into the body to remove the amyloid from the brain. And the red spots here represent where the amyloid is accumulating in the brain. And the left-hand panel is the beginning of the study, and the right-hand panel is 18 months later when the study was done. And this agent, this antibody, literally took the amyloid out of the brain. That's great news. We now know we can do that. The bad news with this study was it didn't make the memory better. So we know we need to expand our targets and look beyond simply taking amyloid out of the brain. But this was a very important study, and if we were to target earlier phases of the disease, that is, before people have the symptoms, we might be able to make much more effect of this medication or this type of medicine in preventing Alzheimer's disease. So one of the things that's important in designing testing of a medicine is picking the right population. When do you test it? So I talked about cholesterol and heart disease. You don't test a cholesterol medicine when a person's in the middle of a heart attack. And so that may be what we've been doing in Alzheimer's disease, is targeting the wrong point in the treatment curve with some of these experimental therapies. We also understand there's a relationship between the amyloid beta and the internal structure of the brain cell. And this is work done by one of my colleagues back when I was at the University of Virginia, Dr. George Bloom in his laboratory, and he was able to model the complicated cell skeleton of the brain cells, but in a test tube type environment. And then when adding amyloid, the Alzheimer protein, to those kinds of cells, he found that it very rapidly dissolved that cell skeleton, or took away the integrity of the cell skeleton. So that gives us a statement saying maybe we can block the effect of the amyloid on the cell. Maybe we don't have to get rid of the amyloid at all, but we can block its effect on the cell. Work being done at UAB by my colleague Dr. Eric Roberson, and you saw his picture in Dr. Standard's presentation, tells us that that might in fact be the right path. Dr. Roberson works with mice that he's engineered to lack a specific protein called the tau protein. The tau protein is very important in the formation of those tangles. And the mouse that he works with produces a lot of amyloid and shows lots of the same patterns that we might see in a person with Alzheimer's disease, heavy accumulation of plaque. But if he prevents the formation of the tau protein, or prevents the action of the tau protein through another one, it's got another funny name called FIN, he's able to preserve the memory of the mice. This is the mice swimming around trying to find a spot. And here is a good memory, even though there's plenty of plaque in the brain. So it tells us that we might be able to interfere with the effects of the amyloid on the memory, even if we can't prevent the accumulation of the plaque. Very exciting movement forward in the field. And Dr. Roberson was just funded to now find the molecules, to use those robots that Dr. Standard showed, to use those robots to find the molecules that could be the next drug to act this way and prevent the progression of Alzheimer's disease. So at UAB, our memory disorders researchers are not as far along the pathway as Dr. Standard and his group in the Parkinson's research, but we're moving in that direction, and it's my goal to bring us rapidly in that direction. It's a cooperative effort with those laboratories in the Center for Neurodegeneration and Experimental Therapeutics. At the clinical end, I handle the memory side of things, and their group handles the movement side of things, but it's a close and cooperative effort. And our memory disorders researchers contribute at multiple levels. And those levels include generating new ideas for treatment targets, coming up with new ideas of where might we want to interfere with the process, and that's going on in our laboratories. And then to prove those concepts in the animal models, just like I showed you with Dr. Roberson's work. Then we want to search for the medicines to hit those targets. And having a chemical that hits a target in a test tube is not as difficult as it is finding something that you can swallow, that distributes through the blood, that gets to the brain, and doesn't cause any problems anywhere else. So finding the molecules that can be drugs is a much more challenging process, and where a lot of that time gets spent in the development of new drugs. Then we need to figure out, what do we test? I talked about some of the tests for these medicines being at the wrong time period. Who do we treat? What do we look for as an outcome? Do we want to measure amyloid in the brain? Do we want to measure memory performance? Or is there something else that we should measure that's important, like how does a family cope with the symptoms? Does the treatment reduce the burden of Alzheimer's symptoms on the person with the illness or their family? And those are all things that may be meaningful as an outcome measure. I have many families tell me, doctor, I'm not so much worried about his memory, but I want him to be able to do this or keep doing that. And so we need to come up with better outcome measures to understand what's important for folks with the illness and what's important for their families. And finally, we don't have all the good ideas in our labs. A lot of good ideas are in the laboratories up in Birmingham. But there are people in San Diego, and people in San Francisco, and people in Paris, and people in Prague who also have good ideas that may be the ones that answer the question. So we not only work on finding those answers working toward the cure in Birmingham, we're part of an international network, a clinical trials network, that allows us to bring the best ideas from other folks in other parts of the world to serve the community here in Alabama. And that's an important part of our mission as well in the clinical trials and the testing of new medicines. So that's what we're doing on the research side. But I'm also a practicing physician. I see patients several days a week in our clinics. I work with folks who are having the memory problems in their families. And so while we're searching for that cure, I am also striving to provide innovative and outstanding care. And there's actually research that's aimed at improving care. And that's another area of focus for me. This is traditionally what happens in Alzheimer's disease. We have the patient and their family, and they see lots of folks. They see a primary care doctor, they see a specialist, they work with a community organization like the support groups, and they might see their druggist for getting their prescriptions, but they have to drive the bus. Each of those interactions is something that the patient or the family has to initiate and respond to, and the doctor might say, well, I'm going to give you a prescription for physical therapy, and it's up to the patient to take that prescription, call the physical therapist, and get the care. Well, that's really hard if you have memory loss, and it's really hard if you're dealing with someone who has memory loss in your family. That's a big burden. So what can we do to relieve those burdens? And the answer is partnership. Partnership between the healthcare team. Oh, my clicker's not working now. Let's see if I can get over here. There we go. Partnership between the healthcare team and the patient and their family, and those community resources like the support groups and the community organizations. And when these partnerships are done properly, they reduce the burden on everyone. Everyone can focus on what they do best. Doctors don't get trained much in counseling. But we're very good at picking the right medicine for the right symptoms. And so people who are good at counseling could contribute more to the care, but we need to engage them. We need to how to engage them and put the network in place. And in the ideal situation, instead of having the patient and family at the center of a wheel where they make everything else rotate around them by their work, is we put a network, we put a safety net in place under the patient and their family through good communication, through partnerships, through the community. And we're working actively at doing this in Birmingham right now with our memory clinic. And this is a model that can be implemented in other communities as well. It worked very well for us in Virginia. But it's all about communication, it's all about openness, and it's about knowing what's out there to help and support. And most importantly, knowing what's important to the patients and the families so that we can direct them to the right places. And so we're actively seeking ways of doing that as well and better understanding what the needs are of people with Alzheimer's disease so we can do a better job of meeting them with our current care while we're looking for that next step, which is the cure. So I'll summarize both of our talks here a little bit, and then I'll move on to questions. But UAB is a world leader in neurodegenerative disease. Doug mentioned that, and it's a true statement. Our current focus is on developing new treatments that protect the brain cells from illnesses like Parkinson's and Alzheimer's disease. We want to protect them against the worsening. We want to try and get them to grow back when possible, and those are our goals. Those treatments are tested at every level, from test tubes to animals to people. All of those are places where we're doing those testing in these crucial and important diseases. And our expertise extends beyond research into the causes of the disease and the cures, but also extends into providing the best possible care for people who are affected by the illnesses and the families and other organizations like the church that support them. So that's the end of my formal presentation. If you need to contact us, I'll just leave these numbers up so that you can write them down, but I'm glad to take questions while this slide is up. Yes? That's a great question. The question is, how do you know if it's Alzheimer's or normal forgetfulness? And there is a point where they're overlapping almost completely. With Alzheimer's disease memory loss, people don't make new memories. That's the crucial part of it. And so someone goes and does something, and then a couple days later they have no recollection of having done that whatsoever. And they'll never remember it again. Healthy aging memory makes us a little bit slow at recall. There's someone we know and we can't come up with their name, but tomorrow it'll pop right into our head. And that's one of the big differences. In Alzheimer's memory, it almost never comes back the next day, and in healthy aging memory, it often comes back spontaneously and unexpectedly. Yes, ma'am.
Alzheimer's, like eat a lot of blueberries, exercise, and get all the blood running around in your head. And, we all have heard those things. You didn't mention anything about that tonight. Is it because we've all heard all those things? Do you think they're valid?
Okay, great question. What can you do as an individual to reduce your risk for Alzheimer's disease is essentially what the question is. And no, I didn't cover it, and because there isn't a definitive answer. The National Institute on Aging had a consensus panel, an expert panel meet last year to review that literature, and their conclusion was there was no proof of any single thing that someone can do that would reduce their risk of Alzheimer's disease. That's the bad news side of the statement. The good news was they said there's lots of evidence to support the ideas of protecting against Alzheimer's, and that we need to do testing to prove those ideas. The things that are best supported for protecting you as an individual against Alzheimer's disease fall into three categories, and you hit two of the three. Regular physical activity. Exercise is important. The surest way of growing new connections between brain cells and animals is to make them exercise. And so the recommendation is exercising 30 minutes a day, 5 days a week. And that level of exercise is enough that we might call it moderate exercise, where you might break a light sweat in indoor conditions. Obviously it's 98, that doesn't count. But indoors, walking briskly enough to break a light sweat. Moderate weightlifting, where you feel the strain in your muscles while you do it. That's the idea of moderate exercise, half an hour, 5 times a week. Number two, mental exercise. Keep your mind engaged, particularly with problem-solving activities, things like puzzles, watching the game shows at Jeopardy and Wheel of Fortune, and answering the questions along with the contestants, trying to beat them. Creative endeavors, photography, painting, ceramics, even things like gardening and yard care count as problem-solving activity. Is it time to mow? Is that a weed or not a weed? Should I trim this branch or not? All of those contribute to good mental performance and help to sustain good mental performance as we grow older. And then the third component is the healthy diet. And the healthy diet, we start with a heart-healthy diet, low in animal fat, high in fiber, and then we supplement it with things like the brightly colored fruits and vegetables. You mentioned blueberries, they're very rich in antioxidants. Any fruit that's brightly colored all the way through, fairly small in size for its amount of skin, those are the healthy ones. And then in the vegetable realm, the brightly colored ones like the carrots and the broccolis and the eggplants seem to have the most antioxidants. The other rule of thumb for diet is if it's white, it's bad. Sugar, salt, starch, those are things you want to steer away from in your diet because they put more strain on the body. They can lead to other complications like high blood pressure. One other factor that's not as clearly defined, but I think the data support, is eating fish. Ocean swimming fish once a week or more seems to reduce your risk of Alzheimer's disease. And so even just a can of tuna each week is probably enough to meet that threshold. So those are things that all of us could do and should be doing. It's not really news. We've known about these things on the whole for a generation because they protect against heart disease. But protecting against brain disease is another reason for doing them. Yes, sir.
Doctor, several years ago, there was a study of a very large group, I think, of veterans. And in that study, it was a health study, they seemed to indicate that people that took certain statins had a greatly reduced risk of Alzheimer's. I was just curious what your thoughts were on that.
So the question is, what about the cholesterol-lowering medicines, the statins, and their influence in Alzheimer's risk? And there is reasonable evidence that people who lower their cholesterol with statin drugs, when they have high cholesterol, end up having a lower risk for developing Alzheimer's disease. However, the same statin drugs have been tested in people who already have the symptoms of Alzheimer's disease, and they've not been shown to slow the progression or alter the symptoms. So it seems to be something that works more on the prevention side than the response to symptoms side of the equation. And in general, if your cholesterol is at a level where your doctor should recommend that you take a cholesterol-lowering drug, you probably want to do that because the benefits, both for heart and brain, are probably there. Studies have been looked at with adding cholesterol-lowering drugs to people whose cholesterol is not elevated, and there have not been as much benefit on the brain in those people. There's one way in the back. I haven't been to this side of the room.
Just after it was both tonight. I want to know, what are the major roadblocks that you see towards more progress? Do you need more money, more time, fewer politicians involved, less bureaucracy? What are the major roadblocks? Both of them, please.
It's a great question, and maybe Dr. Standers is even better to answer this one since he's my boss, but the answer is always, yes, more time and more money. If we look at the amount of funding that goes into neurodegeneration research as a whole, from the federal government, from private organizations, it's much, much less than the amount of money that goes into things like cancer and heart disease. Those are more prevalent diseases, so that's a balance that our society needs to make. And we are facing the challenge of caring for the people with the disease while at the same time seeking the cure, and those are two conflicting demands in time. I'll ask my chairman to address more.
I mean, what we need to solve these is we need smart people to have the time and the resources to work on the problem. I mean, these things are not impossible to solve. I really believe that we can find treatments that will radically alter the course of these diseases. It's possible to do it. We know enough about the brain now to do it, but you need the right minds, and you need them to have the facilities and resources that they need to do it. Some of the things that are going on up in Washington are not helping us terribly much. I have to be honest about that. But budget cutbacks in the NIH and medical research funding is not a good thing for this field. We're fortunate that community people have stepped up, and some of the foundations have stepped up. But if you really look at what funds this kind of research, a lot of it does come out of the National Institutes of Health and the federal government's funding for medical research. So, despite the fact that cutbacks are needed, we should all keep an eye on that particular part of it and try and urge some restraint in that area if we can.
Yes?
My mother's 86. She's been taking Aricept and Namenda for about a year and really have not noticed any, significant changes, if anything, worse in her memory, short-term memory. You talked about current treatment options. What would you suggest generally and specifically there?
Sure. I can only really speak at the general level. We have two classes of medicines available for treating the memory symptoms and related symptoms of Alzheimer's disease. That's the class from which Aricept comes from, and the other members of that class are galantamine and Exelon. So those three all work essentially the same way in the brain, and no one is more potent than the others. One individual might respond better to one than the other, but the rules, the studies show that they're all about the same. And then Namenda is the only class within, the only agent within its class. So those are our current choices. We don't have other things to help with memory progression. In general, those medicines do not markedly improve memory function, but they can delay the worsening or slow the course of the symptoms for a period of time. After a year or so, we often will see that folks are worsening even though they're on those medicines. Yes, ma'am?
Have you heard anything about a female scientist? Somewhere, I think it was in Boston, it was on the news, had said something about Alzheimer's was a form of diabetes, but in the brain.
Yes, there is a group that looks very closely at the interaction between diabetes and Alzheimer's disease, and one group of scientists is, I think for mostly, if you will, advertising purposes, said Alzheimer's is type 3 diabetes. But there are clear links between high blood sugar or high blood insulin and the risk for Alzheimer's disease. People with diabetes are more likely to develop Alzheimer's disease, and people with Alzheimer's disease are more likely to have sugar problems. So there's a clear link there, and some of my own research in clinical trials looks at trying to use agents that can increase the brain's sensitivity to insulin or reduce the burden of diabetes to try and improve the treatment. Studies have shown, however, that just using anti-diabetic drugs does not alter the course or symptoms of Alzheimer's disease once the illness has started. So again, we may want to look at this as more for prevention than response to symptoms. There's a lady in the back who's been very patient.
Till you die, or does it use up its usefulness and there comes a time to discontinue it?
Okay, so the question is, how long do Aricept and Namenda work? And the answer to that is it varies from one person to the next. In general, we expect that their effectiveness will wear off over time, but no study has been done to tell us when to stop it, and that's a real problem. It becomes an individualized decision, and when people are having losses in their everyday function, that are unacceptable, if you will. The family says, I don't think the medicine is working anymore. Then that's a time where I might start to take the medicines away. If they're helping, the person will get worse temporarily when we stop the medicine, and we can put them back on. If the person does not get any worse when we stop the medication, then that's a sign it was no longer adding benefit, and we can stop it without worrying that we're harming the individual. But we don't have any clear guidance about months, years, or specific scores on tests when the medicines work or when they don't. Every one of those decisions is made in a single individual. That's really a question you have to address with the doctors who are caring for them, and if you're not comfortable with the answers you're getting from those doctors, to seek a second opinion. But there isn't a rule on that, again, that says when does one become dominant. It really depends on where the person's struggles and where the family struggles are giving them the most problem, and trying to work to deal with those particular challenges as they come up.
Yeah, I have to agree. We see a lot of people who develop dementia and Parkinson's, and we treat quite a few, but I'm also always in favor of second opinions. If things don't seem to be going well, get another opinion. I'm always interested in other opinions from other physicians. I learn something all the time. I see things all the time I've never seen before in medicine. It's an interesting field, and there are things out there that we don't understand, and I'm always in favor of more knowledge and more understanding.
And I have to echo that. I'm never insulted when a patient or family asks me, is there somewhere else I can get another opinion on this? A fresh set of eyes often helps find new problems. I know when I lose my keys in the kitchen, I ask my wife to help me look for them. It's a fresh set of eyes on the problem, and sometimes that new perspective can add a lot of insight. And each of us has had different experiences with the people we've cared for, and sometimes it'll ring a bell and say, I remember seeing this before, and that will help us solve the problem that's being presented to us at that point. So second opinions are very valuable.
So maybe we should take a break and let people come down, and we can stay for a few minutes. I don't want to keep everyone sitting too long this evening.
Can we express our gratitude to Dr. Gelmark and Standard? And Doug wanted to recognize someone else too.
Yeah, I apologize. Mary Honeycutt is here, and she has been the stalwart behind the Frazier support group for over 15 years now, and I appreciate all you have done for Parkinson's in Montgomery, Mary.
Well, let's have a closing prayer, and afterwards the doctors will be glad to take your questions and talk to folks up here. Thank you so much for coming to be at this gathering, and we hope it's been fruitful to you. Let's pray. Father, we thank you that you have shown us in your Son that you're a miracle-working God, and sometimes you have worked miracles by going with those who are sick, and we thank you for friends and families and communities of faith and others who go with those who are struggling in various ways. But you also work to make the sick person well. And so we thank you for the miracle-working power that you are working through these who research and teach and labor so hard to bring wholeness and healing to those who are afflicted by disease. We pray that you would strengthen them and bless them for the work that they do. In Jesus' name, amen. Thank you.